Okay, there we go. I just couldn't find the right scene in OBS for some reason. I have way too many scenes. Anyway, hello. Welcome back. Playing the natural number game, again, as usual. So yeah, last time we beat Power World. They won't let us beat the last level because it's Fermat's last theorem, so we're not doing that, I guess. But I'm going to consider this 100% completed. So yeah, the only thing that we have left to do is this world and then advanced multiplication world. So yeah, let's start with less than or equals world. In this world, we define A less than or equals B and prove standard facts about it, such as if A is less than or equal to B and B is less than or equal to C, then A is less than or equal to C. Hello, fellow recliners. How many different synonyms for leaners are you gonna find, or lock pickers? The definition of A is less than or equal to B is there exists a number C such that B equals A plus C. So we're going to have to learn a tactic to prove exists theorems, another one to use exists hypotheses. I see. The use tactic, okay. A is less than or equal to B is notation for there exists a C and a B. Oh, no, there exists a C such that B equals A plus C. Okay, I get it now. The backwards E means there exists. So A is less than or equal to B means that there exists a number C such that B equals A plus C. Oh, okay. But I mean, that's sure. I guess they're just trying to show me like how do you read this? This definition works because there are no negative numbers in this game. To prove an exists statement, use the use tactic. Let's see an example. The reason x is less than or equal to x is because x equals x plus 0. So you should start this proof with use 0. Okay. So use 0. You can take it from here. Okay, what did it look like before? Okay, so I have to prove x less than or equal to x. And then I did this, and now it says x equals x plus 0. Okay, sure. Let me reread this, because... So why is that? B equals A plus C. Oh, but yeah, okay, because you could pick like any... Or no, I guess it would have to be some specific C added to A to equal B. But it could be 0 itself, because yeah, it's less than or equals, not strictly less than. Okay, I'm a little bit weirded out by like how it went from this to this. Like, does it always take it to like equals and then plus like that when you use the use tactic? Like, what does use do? The use tactic makes progress with goals which claim something exists. If the goal claims that some x exists with some property, and you know that x equals 37 will work, then use 37 will make progress. Okay. Interesting. So I guess like less than or equals is like special in some way, like in how it's defined. And they said I can take it from here because I probably just do a subst plus, or is it add 0? I think it was like add 0. Oh, right, I need these. Yeah? No? Is it not called subst? What is it called? It is, right? Oh no, it's called rewrite. What am I doing? Okay, and then ruffle. There we go. Okay. Just remembering syntax. To solve this level, you need to use a number C such that x equals 0 plus C. So this is proving 0 is less than or equal to x. If x is a number. Oh, okay, so yeah, x is... Oh, I guess it's kind of more like x is greater than or equal to 0, but... Sure. So I have to use something. I mean, wouldn't I just use 0 again? Or... It's also, you need to use a number c such that x equals 0 plus c. Oh, well then it has to be x. And then I just do, like, rewrite 0 plus, I think? No? What was it called? Oh no, 0 add. 0 add, there we go. And then we ruffle our feathers. If you use the wrong number, you can get stuck with a goal you can't prove. What number will you use here? Good question. So I need to prove that x... if x is a number, then x is less than or equal to suck x. So that's the same as... Wait, what if I just use 0? What happens? Okay, so that shows me suck x equals x plus 0. So I guess it's got to be 1, right? I think that makes sense to me. And then I have to do something. Okay, well, now we have this. I don't think we need it, though. So what do I do with you? I need to rewrite you as suck. How do I do that again? Do I need to add suck? No, probably not. It acts on any statement of a form there exists. It's hard to read less than or equals as like a there exists, though, for me. Like when I'm just like looking at this, I'm just like, I don't... Unless you explicitly have like the there exists, it's not like super obvious to me. Like, okay, so this is definitely right. But I need to do something like to prove that a successor of a number is equal to x plus 1. I feel like that should exist. Is add right? Oh. Or do I need to like unfold? No, not you. Is it 1 equals suck 0? I mean, I guess I could try this. It's just hidden in the definition. There's a few other tactics that allow you to unfold these definitions, but they're not available in this game. Okay, I see. Because use tactics see through definitions. Interesting. Oh, how do I go from here? 1 equals suck 0. I feel like I just gotta try stuff, right? Like, that gives me this. And then I can use add suck, I think. Something plus suck whatever equals. Yeah, so let's do this. This feels very roundabout. And then I can do plus add, I think. No? Or do I need to like specialize on x and 0? Or wait. No, it was add 0, sorry. That's why I'm confused. Oops. Okay, there we go. I'm just like tripping all over the syntax today. Oh, there was a... Wait. Suck, eek, add 1. Where was that? Oh, this one. Oh, okay. So we just had this the entire time. I did not realize. Okay, that is my bad. Huh. Okay, so what would that look like? So if I'm here at this point, this is proof that successor n equals n plus 1. Okay, yeah. Then I can just go exact suck, eek, add 1. X. Huh. Welp. That's kind of silly. In this level, we see inequalities as hypotheses. We have not seen this before. The cases tactic can be used to take hxy apart. Start with cases hxy with a ha. Man, I do not remember how cases works. So hxy is u, but we take it apart with cases. Right, cases was like the one where you do like the case split without necessarily doing inductions. Now HA is a proof that y equals x plus a, and hxy has vanished. Similarly, you can destruct hyz into its parts with cases hyz with bhb. Okay, should I do that? I mean, it sounds like they want me to do that. Now you need to figure out which number to use. See if you can take it from here. So, wait, so I'm allowed to use at this point too, even though I have destructed these less than or equals. Oh, no, because it's in my goal. Okay, I see. So it would change the goal. Right. So that would be the same as z equals x plus some number. Like what? So if x is less than or equal to y, and y is less than or equal to z, x is less than or equal to z. Interesting. Well, wait, we already have an HB that looks similar to this, because this thing would have the form of z equals x plus something. So I think we want to use y. And then b would have to be like x. At least that kind of makes sense to me. Maybe I'm crazy. Maybe I'm wrong. Like, does that make sense? Because z equals y plus some b. We know that x is less than or equal to y. We know that y is less than or equal to z. So it could be like 1, 2, and 3. But it could also be like 1, 3, and 4. Or like 1, 3, and 5. And if it was 1, 3, and 5, then 1 plus 3 is not equal to 5. So that wouldn't be right. So I don't think I want to use y here. So what would it be? Would it be a plus b? Yeah, no, that would make sense. Because, right, y equals x plus a. And I substitute that in. I get z equals x plus a plus b. Okay, no, yeah. I understand now. So that's what I need to do. Okay, yeah, just do the basic algebra. It's like we're playing I Want a Lockpick again. And that's all you have to do. Right, okay. Channel your inner L.A. Watson. Sorry, hold on. I gotta read these messages. What Cases is doing here is deconstructing there exists x such that a statement into a value x and a statement b, since there must exist some value x that satisfies b, where b is a with a variable substituted for x. What? A value x and a statement b. Okay, so like this would be my value and this would be my statement. So x less than or equal to y gets broken into an a and an HA. Y equals x plus a. That's kind of confusing. But I feel like as long as you just like give it two names, like Lean just kind of like does its thing for you. But it is, There exists x such that a into value x statement b. Because there must exist some value x that satisfies b, where b is a with the variable substituted for x. Okay, I think I sort of get it. Yeah, a is for some a, and then this would be that new variable a. Sort of like how they were doing like using like the letter C earlier. Like there exists a C such that a equals b plus c. Or no, I think it was like b equals a plus c. So this would be like the C in that case, and this would be the statement of like b equals a plus c. Got it, I think. Because this thing only talks about an x and a y. So it's interesting that this thing introduces a new, like this has like a third variable in it. So it's able to like translate from this thing that only has 2 variables to this thing that has 3? I just find that very interesting. Extracting the thing that exists because of the there exists statement. Right. I still find it weird that, like, you can go from this thing that only has 2 variables to this thing that has 3 variables, but I don't know. I guess this is, like, just one example of how those works. Maybe we'll see more and then it'll start to make more sense. But anyway, we got a thing to prove. We have a bunch of variables. I think I can do, like, a substitution like I was saying earlier, right? If I want to substitute u into u, how would I do that? I guess I can't really do that, can I? Because, like, is there a way to rewrite another hypothesis? I like reading these. Le suck self. C is hidden by the definition. It would be more clear if the backwards E was there. It would probably be more clear, yeah. So there's like an implicit magic C attached to each of these, I guess. So how would I rewrite? Yeah, what if I want to rewrite my hypothesis? Because I have a hypothesis, I have another hypothesis. Can I do that? Oh, okay, yeah, at. Okay, so if I do rewrite ha at hb, end up with this. Okay, cool. That's like almost what I want. And then we use or not commutativity. We use associativity to fix it. So we want to add a sock. There we go. Hey. Then we can do exact HB, and we win. Level completed! A passing mathematician remarks that with reflexivity and transitivity out of the way, you have proved that less than or equals is a pre-order on n. We did it! Yay! Remember, kids, do not pre-order your video games. It's intuitively obvious that there are no numbers less than 0, but to prove it, you'll need a result which you showed in Advanced Addition World. Okay. When did we do that? Okay, so now we have le trans. Le raffle. Oh. Yeah, shout outs to that guy. We have le zero. Okay, so how do I do this? So this is still use world, right? We still want to use French moment. Ho ho ho, baguette. So I probably should. Oh, but it's in my HX. So I probably want to cases U. AHA maybe? Sure, we introduced an A. We got this. And I need a result from Advanced Edition World, really? What did I do in Advanced Edition World? This? Oh, okay. It must be this then. Is there an add left? Eq 0? Wait, what's the difference? Wait, no, wrong one. Wrong one. Add right eq 0. You know what I just realized? Like this is just a pane that appears over top of this stuff in the background. That's why it cuts off like this. It's not a glitch per se. It's just a very weird way of displaying things. Like they could have had like a little border to show the boundary. Like this is just a card being overlaid on top of this. Wait, isn't this the same thing? Oh no, this is an implication. Oh, so I need to like swap the sides, right? Yeah, I feel like we want you. And yeah, we don't want you because we're not using the B. We need to use. How do I swap this around? I don't remember if I have anything like that. I feel like it's not related to addition though. This is transitivity. This is nothing useful. Yeah, where is the thing that lets me move one thing from one side to the other? That can be done with sim, in case you forgot. Oh, sim. Ah, there we go. Okay, thank you. Yeah, I did forget. Right, that is the property of symmetry. I need to remember that. Wait, no, it's not that. It's sim. It's literally sim. Sim ha. No. Wait, how does this work? How do I sim? Sim at. Why is it sim at? Okay, sure. Well, why not? Sim at. Oh, because it changes the goal otherwise. Okay, I see. So if I don't at, then I don't affect the hypothesis. So now I can use my add right eq 0, right? Or I guess I'd have to like apply it. Huh? Okay, how do I apply? Apply. I guess I'm not really. But no, I am. Okay, how do I do this again? Apply T at H. At ha. There we go. And then I can refull, and then we're good. No? Oh no, exact. It's exact HA. There we go. Exact ha. This level asks you to prove anti-symmetry of less than or equals. In other words, if x is less than or equals to y, and y is less than or equal to x, then x equals y. It's the trickiest one so far. Good luck. Oh boy. So I gotta cases both of you. So we're gonna take hxy with AHA, and we're gonna cases hyx with BHB. Okay. Maybe this is the hardest one. Ooh. Okay, so what's the story Wishbone? Oh, because these guys are like defined in terms of each other. I see. Hmm. That is tricky. So what do I need to do here? Y equals x plus a. X equals y plus b. I have no idea. I have absolutely no clue. I guess I have things that I might be able to use now. I don't know about that one. That's reflexivity, maybe. So x is less than or equal to itself. We have 0 less than or equal to x. We have le 0. If x is less than or equal to 0, then x equals 0. And this is transitivity. Which I don't think we need. Oh, but maybe. Because no one said that z can't be x again. But does that help me get to my goal? This seems useful though, because yeah, because I have. Okay, let's start over. Let's start over. Let's start over. So I think I want to is it rewrite? This is not an equality though. Or yeah, this is an inequality. Does this work? Uh Oh, but I need to Well, what am I rewriting? That is true. I think what I actually want maybe is but this looks so similar, right? Like like this should produce a thing that I can use. Okay, what does this say? If x is equal, okay, less than or equal to y is less than or equal to z, then x less than or equal to z. This is proof that x less than or equal to y implies y less than or equal to z implies x less than or equal to z. I don't care about the associativity. I feel like I just want to use it. This is the trickiest one. Ooh, okay. I feel like I need to use this, though. It feels... Because then I could just have, like, x less than or equal to x, which then I can prove with this, right? Maybe I just need to apply... Because I can, like, curry this, sort of. Apply... the trans. Yeah, I need to apply at hxy, and that gives me u. But then I can... How do I double apply? Can I apply again? I guess I could, because now it has a new thing. But... Okay, but no, okay, hxy is now a thing. So now I can apply that at hyx? Okay, there we go. Yeah. So that's what I can do. And now I have a proof of x is less than or equal to x. Which doesn't really help me reach my goal, does it? Does it? Something tells me that this didn't help me. What do you actually get when you use it? And it is also completely trivial. That is true. I don't know, I thought it would be useful. I guess not, though. So maybe this isn't right. Okay, fine, it's not right. I don't know what I'm doing. Okay, let's go back to the original approach. What am I trying to do though? Like, I need to get an x equals y somehow out of this, but how? Like, substitution won't work, will it? Or maybe it will. Hold on. I feel like I've done something like this before in I Want a Lockpick. So if I do rewrite HA with, or like at HB, I get this. It kind of mutates my HB though into something else when I rewrite it like that. I don't know if I want that. Also, this just feels like it's leading towards just like x equals x, which is not very helpful. Do I need to get rid of the A and the B somehow? Like, if I could, like, isolate the A and then substitute it with X and Y's, and same with the B, like, maybe that would do it? Because that sounds like the... That sounds like what I want to do. I want to be the proof assistant. Ah. There's a new game for the I Wanna series. Yeah, I'm pretty sure I want to just isolate the B and the A, but I want to keep my HA and HB. Is there a way I can do that? I guess I could, like, no, if I cases again, it's just gonna introduce more stuff. It'll consider those to be like different numbers, I think. I want to like clone my hypothesis so I can like rewrite it later. I don't remember if I got anything to do that though. Also, yeah, we still have U's. I haven't used the U's. But also, there's no goal. There's no such goal to use with. So no, I don't think it's that. Oh my god, how do I do this? Is there a way to do it without doing like a bunch of substitution? Like, I feel like I just want to get A and B isolated so that I can like substitute them out. But then, okay, if I were to... I guess we don't really have a thing for that, though, do we? Do we have subtraction? I don't think we do. Because I can't go, like, A equals Y minus X. That doesn't exist. We don't have that. So I couldn't do that. What? Why is this so hard? You can make copies with the have tactic, but you don't actually need it for this level. Really? Okay, what am I missing? Maybe I rewrite the goal. Okay, hold on. Let me rewrite the goal. Rewrite. So you're just x equals y, but I can get rid of the y with HA. So I can go like HA. Yeah. No, nothing specified, and that just rewrites that goal. Okay. Wait, isn't this like really trivial? Because x plus a. If x equals x plus a, shouldn't that imply that a is 0? Like, shouldn't we already know that? So I don't really know what I'm doing here with HB. I feel like I don't need that. X equals x plus a. Like, surely we've done something like this, right? Yeah, look at this. Add right eq self gives me something like that. So if I sim the goal, then I can rewrite with add right. Oh no, not rewrite. I guess I would have to apply. Apply add right eq self. Why are you not happy with that? Do I have to give you arguments? Like, I want to prove that... Oh wait, but I don't. You're not the hypothesis. Yeah, I can't think the goal is true. Oh no. But it's it looks so similar. So I guess I can't do that. So I need to prove that A equals 0? Is that it? Well, that's annoying. How do I do that? Is there anything else? So if I had this as a hypothesis, I would be okay. If I don't. Oh, so wait, this is like right. So this only goes one way. If it was like the double arrow, like the if and only if, then I would have been okay. Right? I think maybe not. I mean, I'd still need to have proof that A is 0, right? Yeah, I'm trying to prove that x plus some number A is equal to x. So in order to prove that, I must prove that A equals 0. Okay. I think that's not like super hard to do necessarily. I mean, I guess I don't really need the sim then in that case. What to do with you though? Maybe I'm thinking about this wrong. Like, did I not want to do this rewrite? Because I could do this rewrite on the goal at any time. I could do it earlier here. X equals y plus b. So that gets b involved. Do I want to get b involved? Also, how would that help? My brain hurts. You can definitely use that theorem you just tried to use, just elsewhere. Oh. But how? But how? How, Elmo? How? X plus y equals x. Here? Oh, wait, yeah. Wait a minute. Wait, yeah, no. Hold on. Okay, let's not rewrite the goal just yet, maybe? Actually, I don't know. I don't really care. We don't care. Wait, yeah, no, if I use add a sock, don't I get something of the right form here? Yeah, x equals x plus that thing. But then if I use sim at HB, that looks pretty good. So now I can use apply add right eq self at HB, right? Okay. So a plus b equals 0. We have a 0. We have a 0. So now what? Add 0? Well, they have to both be 0, right? So I have to prove that they're both 0 from here. But this looks doable, right? Add right cancel, maybe? Because I need to like decompose this into like a equals 0. But I have an a plus b equals 0. But they're both 0. Oh my god. Is that really not it? Am I stuck? No way. This can't be it. This cannot be it. But this is like the perfect thing. No? Oh, maybe I don't. What if I didn't do it that way? Wait, yeah, what if instead of making a plus b equals 0, what if I just went... What if I proved that b was 0? Or something, wait. No, but the terms have to be the same on both sides. So if I didn't add associativity, it wouldn't be the right form. I feel like this is the right thing to do, though. Like, I have to group the A and B. And then I'm able to apply this. And I get a plus b equals 0. So I feel like there has to be a way to get from here to there. Because, yeah, the term needs to appear on both sides of the thing. There must be like a, if a plus 0 equals anything, then a equals 0, right? I think that has to be a thing. So it has to be one of those like if something something. It's not you. Oh, here we go. 0. No, wait, no. 0 out is a simp lemma because replacing 0 plus x by x is almost always what you want to do when you're simplifying an expression. Have we never seen... anything like this before, though? No, these are all less than or equals. That's not helpful. Oh, I might have... Add left, cancel? Like, I feel like if I rewrote u as, like, x plus 0... No, then it would still be... That would just put me back at the same place I'm currently at. So that's not helpful. Didn't you prove that already? I used it just last level? I did? Did I? Is it this guy? Oh, yeah, it is. I'm blind. I'm stupid. Help. Helpers. Add 0. Oh my god. Okay, fine. Ruffle. Ruffling my feathers. I didn't need to do this, huh? Or did I? No, I did. No, all of that was necessary. Everything necessary. Okay. Here's my proof. Ugh. Oh, hey, mine's looks exactly identical to their proof. Wow. Jeez. Hell. What the hell was this level? Oh my god. A passing mathematician remarks that with anti-symmetry as well, you prove that less than or equals is a partial order on n. The boss level of this this world is to prove that less than or equals is a total order. Let's learn 2 more easy tactics first. Okay, back to Easyville. Okay, it's 7-Eleven. Totality of less than or equals is the boss level of this world, and it's coming up next. It says that if A and B are naturals, then either A is less than or equal to B, or B is less than or equal to A. But we haven't talked about OR at all. Here's our run-through. OR. So the notation for OR is this V. You won't need to type it, but you can type it with \OR. Oh. If you have an OR statement in the goal, then 2 tactics make progress, left and right. But don't choose a direction unless your hypotheses guarantee that it's the correct one. You can have an OR statement as a hypothesis H. Then cases H with H1, H2 will create 2 goals, where one where you went left and the other where you went right. We don't know whether to go left or right yet, so we'll start with cases H with X, or with HX, HY. Okie dokie. Right, so this is like case splitting on like an either. And haggle. Haggle. Now we can prove the OR statement by proving the statement on the right, so use the right tactic. I can? Really? Is that true? Where's my HY? Where did HY go? I have an HX here. Where'd my HY go, though? The right tactic. Oh, okay. That applies to the goal. And then I can do exact HX, yeah? Okay. Now we get hy. I see. So we need to do them one at a time. So it just chooses the left goal and then does the right goal. I see. So now okay, so now I need to the left. And now I can exact hy. Are you ready for the boss? No? This is the toughest level yet. Tips. If A is a number, then cases A with B will split into cases A equals 0 and A equals suck B. Don't go left or right until your hypotheses guarantee that you can prove the resulting goal. I've left hidden hints. If you need them, retry from the beginning and click on show more help. Oh boy. Is this the boss? But there's still like 3 more levels after this, isn't there? This is the toughest level though. Or at least the toughest level yet. So I guess it gets even harder? I feel like I want to start with the cases. Oh, but no, I don't have a thing I can cases on. Okay. And don't go left or right until you can prove the resulting goal. Oh, geez. Okay, I could take a hint. Okay, we got if A is a number, then cases A with B will split into cases A equals 0 and A equals suck B. Oh, that sounds like hell. This sounds like hell. Are you serious? Well, I mean, that sounds like I need to start with that. Like, that's my opening move. Oh. Oh no. Oh no. Oh, this is terrifying. This is terrifying. Wait a minute. Okay. What if I cases Y with K2? Okay, let's go K1, K2. So now I can go left. And then this should be trivial by... Okay, we did also unlock Le Anti-Sim. So I should try to remember that this exists if it is ever relevant, which I don't think it is currently. I have Le Zero. But I don't think I need that because I have Le Raffle. So wait, how do I Le Raffle? Do I just Le Raffle? 0? Unknown tactic. Do I need to rewrite? Or no, or is it like exact? Okay, I did it. So now we need to prove this. This sounds like a nightmare. This seems like a nightmare. I don't know. Why would I want suck K2? Okay, well I know that it can't be right. Because suck K2 can never be less than or equal to 0. So I know it has to be the left one that is possible. Do I need to use the sorry? Okay, that looks like it's working so far. Okay, and then I ruffle. Ruffle. Yes. Ruffle my feathers. Okay, now we're at the last goal, I think. It looks like the last goal. I don't see any other goal. So, how do I goal from here? So, K2 is gone. We just have K1 and Y. I don't really have anything else to work with, right? I don't really have any stuff here. Do I need a cases again? Is that how that works? Or am I just putting myself in a corner? Because then I have this goal over here. I mean, like, I could try this again, I guess. Yeah, get rid of you. Now we're okay. Now we're in this case. Isn't there like a thing that allows me to remove the suck? But then, how would I ever prove that K1 is less than or equal to K2? I can't like define them in terms of other things. Wait, this feels like induction now. Because I can prove that K1, because I can remove the suck from both sides. I just incremented everything. This level's evil. I think when I first got here, I just incremented everything. Yeah, I know. This is bad. I don't think this is. I don't think this is helping me. Show more help. I feel like I might be going the wrong way. I might be going the wrong way. Also, just a reminder, you've already proven that 0 is less than or equal to anything earlier. Oh, you're right. I totally did do that, didn't I? Okay, I didn't need to do things the complicated way I was doing them. Okay, so left, exact, 0, le, and then suck deep 2. Oh, I need to print the size. I mean, this kind of looks... this kind of looks like something, maybe? Okay, successor of D1 is less than or equal to Y. I have D1 is less than or equal to Y. But the successor is out here. No, I probably want this, don't I? So if Y is less than or equal to D1, then Y is less than or equal to successor of D1. That would make more sense. Oh, I can skip the second induction. Oh. Oops. So I could just use exact 0 le Y. But then I still end up here, don't I? So I'm here. I shouldn't have taken the left, I don't think. No, I think I want to take the right. Right makes more sense to me. Oh, wait a minute. But my hypothesis is like that. I see. Oh, what do I, how, I forget how cases works. I think it's like this, right? Naming our greatest enemy. Yeah, it sure is. Oh my god, I don't know if I can do this. I don't know if I'm beating this today. Because I don't know what to do with that hypothesis. The hypothesis is really like the fact that it's a or makes things hard. I feel like the only thing I can do though is case split on it. I might have to prove something like is impossible or whatever. Yeah. Well, so in this case, I would probably take left. I mean, they look more similar to each other, but okay. If D1 is less than or equal to Y, which one I want to prove? Y is less than or equal to successor of D1. Well, that doesn't seem like that would work. No, I feel like I want to take left. So if U are less than or equal to U, I have to prove that the successor of U is still less than or equal to U. But I don't see like an obvious contradiction though. I feel like I'm going the wrong way. Successor of D1 less than or equal to Y. There's no way, right? Like, is there anything I could possibly do here? Anti-symmetry is interesting here. If I took the right side, because this says that if D1 is less than or equal to Y, and prove that Y is less than or equal to the successor of D1. No, that's not, that's my goal. That's not one of my hypotheses. Remember the description. If A is a number, then cases A with B will split into cases A equals 0 and A equals suck B. Is that so? Okay. I feel like I'm getting closer, but I also do not know. Okay, let's try left again. Cases Y with, oh boy, H give them funnier names. Give them more funny names. This is the hardest level of the natural number game? Okay. Alright, so this is basically like graduation. Well, I know that this can't be the case. I can never prove this. Is there a way to like just say, hey, like reject that goal because it's stupid? There is a way to do that, right? I think we had a like. I feel like there was a thing that we were able to do that. Oh yeah, here we go. We can do something like this, I think. But then I need to like rewrite you, right? Hmm. Shouldn't go left or right until you're sure you can prove it. Ah, I can't. It's so hard. I can't prove either of these though, right? Is this right then? D1 less than or equal to Y. Y less than or equal to the successor of D1. Like this is weird. I guess this is at least maybe possible. But it's only possible if D1 is equal to Y, right? So I guess I would need to prove that D1 equals Y. Or something. This is so... Can I give them primes in their names? Y less than or equal to 1. But this says that 0 is less than or equal to Y. So that doesn't make any sense. Unless Y is 1. I need to do it on Y? I mean, this is something I can prove. Le 0 or yeah, 0 I mean, sure, I can do that. But okay, D1 less than or equal to successor of HA prime. Now let me look at this. Oh god. This is only the first case? See, I don't think this lets me prove this though, right? Like, I don't think that's enough. Like, the only way that would ever work is if this guy was equal to a D1, but it says that D1 is less than or equal to this. So I don't think this works either. I failed at right. So it was left, or was it neither? Because I tried going left last time, and it was, like, not really working. I feel like I should be able to, like, rewrite this goal somehow so that if I can prove that this is nonsense. Well, doesn't this prove that D1 is 0? Not through U. Yeah, through U. So I could do this. Now this is, like, absolute nonsense. Nonsense thing you're thinking of can only be done if your hypothesis is nonsense. Really? So if the goal isn't, so if the goal is nonsense, I can't, like, dismiss it as, like, this is impossible. Like, this case doesn't make sense. But I was able to prove this at some point, right? Your goal is to prove it. You can't just say not to a goal. Yes, you can. Can't you? I'm pretty sure you can. I mean, if the goal is clearly nonsense, then, like, why wouldn't you be able to? I mean, like, if that's the case, and I'm not allowed to do this, then, like, clearly I've already... So that means I can't do this. I think that's what that says. Oh, right. If I can prove false, then... Oh, so that's basically just a way of telling me that what I'm trying to do is impossible. Like, I just can't solve that. So I can't solve either of them if I do this. So that means I'm stuck. That means that this is all wrong. Up to here. I guess I probably don't want to do induction. But then what do I do? What am I supposed to do? I mean, it's clear that I need to do this. Like, they're telling me to do something like this. So if I have... Okay, hold on. Let's think this through. So if I go 0... If I do LE 0, then I can prove the left one. Oh wait, no. I can prove the right one. So was it exact LE0 at... No. Why? No, it's not that. It's apply. Actually, my brain hurts. Wait, how does this work again? Like, I was doing this earlier, wasn't I? Oh, no, that's my goal. Okay, so this one I can exact LE raffle, I think. No? Induction was the right move? I had the right first 5 lines? Really? That's crazy. So you're saying that I can actually do this? There is a way to go from here to victory. There actually is a way to get from here to the goal. What did I do? I did a cases with Y. Maybe I wanted cases with D1 instead. But suck 0 less than or equal to Y. I can't prove that either. Do I need to do cases Y as well? But no, because I can't prove suck 0 is less than or equal to 0. That's not possible. So no, it's not that. This was winnable? That left is wrong. You meant the first 4 lines. So it's neither left nor right, is what you're saying. I can't prove this with a left or a right. Huh. You have to do more work before choosing left or right. Oh. Holy moly. What the hell is this puzzle? No, I can't. But I can't like use at this. That doesn't work on use doesn't work on hypothesis, does it? Okay, well, You need to case split before picking. Then you can choose different branches for each split. Oh. For real? So if I did like cases D1... If I did cases Y? Okay, I mean, that one looks more promising. I see a 0 less than equals suck. I can do that. Sure. If I do this, I can definitely use 0 less than or equals, right? But wait, no, we're proving... Oh, wait. We don't need HA in this case, right? Because I can just exact 0 LE and then give it suck D1. Okay, yeah, no. So that's fine. I can do that. Sure. Also, case splitting on a number only needs one new variable name. It's not a hypothesis. Oh, wait, really? Oh. So this is more like just K. Oh, okay, I see. Got it. And then I can do the left side of this one. And then I can apply symmetry? Is it? No, not. It's not symmetry. There was another one. There was a thing where if you applied the thing on the left and the right hand sides of the equality. Was it symmetry? No. No, this is. Right, that just swaps the order. Wasn't you, was it? No, no, no. What is this? Oh, that's just cases. Side. What was the thing? I can't remember. It wasn't this. Was it not a tactic? Maybe it wasn't a tactic. Because nothing else here looks like what I'm thinking of. This thingy. Not you. Okay. Yeah, no, it was you, right? But you're the wrong way around. But also, this is an inequality. I didn't realize that. But also, this is not the same form. Wait. What? I'm seeing things where they don't exist. Okay, I'm sorry. I don't know what I'm doing. I am seeing ghosts. Wait. Go back. Go back. Hold on. Wait, isn't this exactly the same situation I was in before, though, basically? It kind of feels like it is. I can't prove either of these directly. I don't think this was the right move. Wait, go back, go back, go back, go back, go back. Okay, let me read more of this. Okay, no, yeah, no, I'm still there. Hello, welcome, Dark Troden. Oh, more new faces. Welcome to the stream. Okay, am I correct up till here? Or have I put myself in a hole? Remember me. That's an ominous ominous warning, maybe? Or are you asking if I remember you? I don't think I've seen the name Dark Trodren. No. There's more I can do before splitting on Y? Are you freaking serious? More I can do before I split on Y. . Do I need to do induction again? Do I need to do induction on why? Do you remember me? It was Dark Shodren, but now it's not. No, I actually don't. There's something you can do with HA. Really? I can do more with HA? Wait, can I operate on my hypothesis? For real? Wait, what if I case as HA? I never thought about this. Why didn't I not think about this? I can do this. Yeah, you can cases on a inequality. Oh, I can't remember. Is this one? This one was the one with like C and like HC or whatever, right? Or something like that. I seem to recall. What did you do with inequalities as a hypothesis in the past? This. I did this. I was a couple months ago. I asked you to play Roblox, and then I joined stream on other accounts. Oh, you're that guy. What the hell? You have no. Of course, I don't remember your name because you use like a billion different names. Did you say you were like 7 years old or something, or like your brother was, or like you and your brother are both like under the age of 10 or something, which would honestly kind of check out. I mean, you probably shouldn't even be here, to be honest. This is a stream that is marked for not for children. Okay, so now I have y equals d1 plus c. Okay. So I could probably do a left here. Then I can do a substitution. I can rewrite on y with hc. I mean, so far this seems okay. Because I can turn a plus into something else. Yeah, very scary math. Lean is not safe for children. For the record, Pi, he joined during one of the early lockpick streams. And that was also the same stream where Imaginatory ended up with moderator status. So there you have it. But this is not successor of A plus B. Oh, can I now... Do I need to use... Oh man, this is... There has to be some theorem for this one, right? But it's not this. Because I want to be able to like... But that would use pred, wouldn't it? I think we have this. Does that help though? You can find a counterexample to the statement I'm trying to prove. Really? So I'm barking up the wrong tree is what you're saying. Oh, if C is 0? Yeah, I guess that would be true. I didn't think about that. So if C is 0, then this is false. So yeah, I can't prove this. Okay. So I'm not doing the right thing here at all. So that means I can't prove this. So that means it's not left. It's definitely not left. Does that mean that this is impossible? Do I have to further break things down? This is this has to be the right case. I have to be on the right track up till line 6, I think. Okay, I think they're gone. I think they left. If only you could do something else when C equals 0. If only I could do something else when C equals 0. What does that mean? So okay, so left is wrong. So if C equals 0, then Y equals D1, and suck D1 cannot be less than or equal to D1. That will never be. I can't prove that. Do I need a case split on C? or is this how far we're going? I mean, I guess I haven't case split on a number yet. Do I even need to do that? That's an even better question. I could use yeah, do I need a case split on C? I guess I don't need to, but I mean I could. I don't think it would hurt to do it. Because I feel like I could take the right side, replace this with D1 plus C, less than or equal to successor of D1. But no, then I could pick a C that's just greater than 1. Right? Yeah. Then I can do... Sure. I can do that. If you find a counterexample of both paths, then you definitely need to do something other than left or right. Oh, is that the case? So that means I don't want to do this. Wait, hold on. Did I? Well, no, I didn't find a counterexample here, though. But do I have a counterexample at this point? So y is d1 plus successor of k. I don't know. This doesn't look good. That message was sent earlier? Oh. I think I'm stuck. I think this might be impossible. Because I can't do anything with this. Like if I substitute u into here, successor of d1 less than or equal to d1 plus. Oh, but no, but now I've gotten rid of that 0 case. Oh, wait, no, this is possible, isn't it? Because now we have to, because it has to be with plus at least 1. Wait, no, yeah. So if I rewrite HC, because yeah, before the C could have been 0 and that would have gotten me trapped. But now it has to be at least 1. So now I can add suck. I can use add suck. Okay, hold up. Okay, well, I guess I could just do that here, right? And that seems pretty good. Because, like, d1 plus k, even if k was 0, it wouldn't matter. So now it should be true no matter what. So that's... This feels like I'm on the right track. So how do I go from here to something more productive? Yeah, I just did this. Oh, it's like almost there. If like, because I could convert this into a successor of something else. How did I prove inequalities earlier? I used the use. Use k? Is that right? Because D, okay, so yeah, like if it was like 1 plus 1, and then I add another 1, that'd be the same as, well, I guess I should pick different numbers. If this was like 1 plus 2, that'd be 3. 3 plus 1 is 4. If it's 1 plus 1, that's 2. 2 plus 2 is 4. Yeah, that makes sense. I think that's right. So if I use K, there's a rule for this, isn't there? I don't remember what it was. But it looked kind of like this, I think. Or was it the one I was just looking at? Is it this one? It is this one, isn't it? Did I need to do this? I'm not sure I actually wanted to do this. I feel like maybe I didn't want to do this. But okay, whatever. It doesn't matter. We're gonna we're here now. So A plus suck B equals that. So I should be able to rewrite add suck somewhere here, right? Maybe I have to like reverse it. Oh no, but now it's the wrong way around. It'll suck add. Oh, that suck add. Right, okay. Hey, there we go. Holy moly. We're still not done. We're still not done. Well, can I not just... So, if y is less than or equal to d1, then y is less than or equal to the successor of d1, right? Like, that isn't this trivial? This should be trivial. I swear there's, like, a thing for this. Right? That's the only one with suck, though, isn't it? But I know that this is doable. This has to be provable at this point. You could solve it with a one-liner from here, really? No. Why do I do this to myself? It's right. It has to be right. I know that it's right. But it's not obvious? It's not an obvious one-liner? Okay, well... I could use cases again. It just feels like this should be really doable. Can I use transitivity here? Because if y is less than or equal to d1, and d1 is less than or equal to the successor of d1, then y should be less than or equal to the successor of d1. No, this is it, isn't it? I should be able to exact with this as the first argument. Or do I want to like apply it? Oops. No, I feel like there's a thing I can do with u. And then I would need to prove that d1 is less than or equal to successor of d1, but I could do that with this. Oh man. LE trans has 5 arguments? Oh, it does. It takes X, Y, and Z. I did not see that. Oh. Okay, so in that case, it would be Y would be the first one. And then the middle one would be D1. And then the last one would be suck D1. Wow! Finally, okay. Well, very well done. A passing mathematician remarks that you've just proved that n is totally ordered. The final few levels in this world are much easier. Holy moly. How long was your proof? 16 lines, yikes. Yikes. We're out. We're free from prison. Yippee. We've proved that x is less than or equal to 0 implies x equals 0. The last 2 levels in this world will prove which numbers are less than or equal to 1 and less than or equal to 2. This lemma will be helpful for them. Okay, this lemma will be helpful for the last 2 levels in this world. Suck la suck. Oh, my brain just feels so melted. The last part would be a bit easier if you just use like a normal person. No. Le trans. We don't do things normal here. I have le total. Is this gonna be helpful here? What are we doing? So if suck x is less than or equal to suck y, then x is less than or equal to y. Oh, okay. I see. Interesting. This does not seem like this is helpful. That's x less than or equal to y, or y is less than or equal to x. Yeah, no, I don't think that's helpful here. You had 22 lines. Also didn't have a lean 100% or helping me in chat. That is true. So, where do I even begin? Should I use... But what would I even add? I guess I could cases here. And what do they do? They're like AHA or something like that? Uh-huh. You had to use the sleep buff for that level. Oh, geez. That sounds pretty crazy. Oi, 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 oi. Is that right? No. Because we have successor of y equals successor of x plus a. That's y plus 1 equals x plus 1 plus a. So we have to add another 1, don't we? But I don't have a successor of y. Would not have found that one-liner if not for future experience. I see. This seems like it could eventually work if I just like rearrange stuff. Can I like... I don't like that this is on this side. Like, is there a way I can like move a successor to the other side? When in doubt, substitute the variables for normal numbers. Am I doing this wrong? Okay, so like if this was like a 1, you're a 2 and you're like a 3. So it'd be 2. Oh wait, no, that would not work. Wait, I think I might be I think I might be crazy. Okay, so if you're a 1 and you're a 2, then this would be like 2 plus 2, which would equal to 4, which would mean that y would actually be equal to 3. So if you're a 1 and you're a 2, 2 plus 1 is 3, 3 plus 1 is 4, 4 plus 1 is 5, so no. I actually want... Oh wait, don't I just want... I don't want any of these. Well, yeah, no, that makes sense. Yeah, no, that makes more sense. Okay, but then how do I get anything out of this? Do I have to add suck again or suck add? I think we need to like take you and like put a suck around both sides, and I think there's this for that. Except no, it's the other way around. Oh, but then I could turn you into this form, and then I could lower you down, right? Yeah, it's suck add. Okay, suck add on you, and then there we go. Now I can rewrite. What is it called? Suck inge at HA. Or no? Oh no, great, because you're not a rewrite. I would have to like apply you. There we go, and now I can just ruffle. Or no, not ruffle, exact. There we go. Ugh. And there's their proof, and it's exactly the same as mine. Okay. Youch. We've seen le zero, the proof that if x is less than or equal to 0, then x equals 0. Now we'll prove that if x is less than or equal to 1, then x equals 0 or x equals 1. Okay, so they gave me a thing that they said would be very useful right here. So I need to use this at some point. I remember they said that this is useful, and it's going to be useful for the next level too. Oh boy. So we got more of this or nonsense again. They did not pull their punches in this world. So let's see. Do I want to left or right? I do not believe I do. So, well, we know that less is x is less than or equal to 1, but that doesn't mean that it is 1. So we probably need a case split on hx. I know, I actually remembered something for once. Okay, so we have 1 equals x plus a. I'm wondering when this will become useful then. Or was it immediately useful somehow? What was this again? Suck le suck. It was if we have a successor on both sides, then we can we can strip the successors from both sides, which makes sense. So when is that going to happen, though? Because if I'm casing like this, I don't really see why that would be the case. But then I guess I'd have to prove that a equals 0 if I wanted to prove that x equals 1, if I want to go right. So I guess I don't want to go left or right yet. Because I don't think I can prove either of these with what I have. Yeah, less than or equals world is crazy. Thinky puzzle gamers don't know how crazy less than or equals world goes. So I guess, do I want to rewrite you then? As like, what, as this? Because that would give me a suck. Because like, if I'm working towards using that thing, I feel like this might be something I want to do. Okay, well that wasn't exactly what I had in mind. Like if I do this, and then, well, not this. Actually, can I turn you into something else? Maybe not. Definitely an 11 on the difficulty scale. Ugh. I mean, even these much easier ones are not that easy. I feel, wait, no, but I've lost I've lost this at this point. So did I not want to start with cases then? But then, no, how would I use this on this? It's not the right form. There's no... I mean, I guess I could like suck pred or something, but... I don't really feel like that's going in the right direction. I'm also not sure if this is helping me. I guess I could substitute. Like if I picked one of these sides, well, no, I can't. I can't just like rewrite this, can I? Will that even work? If x is equal to x plus a, wasn't there something for this though? I swear there was. Ugh, I can't remember anything. This thing. Like if I were to, okay, let's ignore you for now. Was it this? No. This? Right. Okay. I think that was it. What if I rewrite? Okay. Well, okay. Why don't we go right and then we rewrite? Like that. Well, then that gives me that as my goal, but that's not a hypothesis, right? I had this problem before. Yeah, so I can't do that. So I don't think... Yeah, I don't know. Okay, I want to keep the inequality. Okay, that's kind of what I was thinking. So that means I don't cases here. If I want to keep the inequality, then what do I need to do? How do I keep the inequality here? Induction on X. I mean, that would keep my inequality, I guess, but no, then we just get that as our inequality. Is that useful? Well, that's not even of the right form. We don't have a suck on the left side anymore in this case. I guess we would have one in the other case, though. This is, I don't know, I might be going down like a crazy rabbit hole here. I might be going crazy. Sure, like I could do that. Is that helpful though? Oh yeah, here we go. This guy has, so HX has a thing. Where did HX come from? I don't know. Wait, no, the HX is here. Oh yeah, no, that's right. Wait, are you telling me I always had that? But it didn't have a successor in front of it before. Oh. Huh. Well, that's interesting. It's not too far off. I do want to separate the cases where x equals 0 versus everything else. Oh, I'm stupid. I don't want to do induction. Well, yeah, of course, it's not like a proof for all x or whatever. Okay, I just need to do cases on x. And this is a number, so I just need to do like something like that. Okay. Now that makes a lot of sense. That's kind of silly. So I left, I refool. Now we have this, and this is way simpler. Everybody's happy. Or at least I think everybody's happy. Can I rage quit? Yes, the rage quit tactic. That's my favorite tactic. The one where I rage quit. Okay, so I just rewrite with no, it was this. I need to rewrite one. Wait, no, not equals 0. 1 equals suck 0 at hx. And now I can apply u suck le suck at hx. Why do you not like this? Is this a... Oh wait, no, of course I can't rewrite. It's a apply. Okay, so now I have u, k less than or equal to 0. And I have to prove one of these two things. Well, wait, I can prove that k is 0 because I have I have le 0, right? Apply le 0 at hx. Now I have k equals 0. Aha! And now I know I have to prove the right side. So I can substitute k. With hx, yes. And that allows me to rewrite this using this guy. 1 equals suck 0. And then we can ruffle. Hallelujah. Okay, what did they do? Okay, yeah, they did the same thing, basically. Sheesh. If you solve this all, then you should be fine with the next level. Okay, so this is just do it again, but even harder. Do it harder. I have a low 1. Low 1. You need to know that OR is right associative. This means that x equals 0 or x equals 1 or x equals 2 actually means this. Oh, really? Huh, why is it right associative? Why would you do it that way instead of making it left associative? That's weird. I feel like normally it's left associative when you're like just like ORing a bunch of like booleans together. Like in like your if conditions. But okay, sure, we'll do this. Alright, so we got x less than or equal to 2 this time. They said that, wait, no. Suck less suck would be useful for both of these levels. So that means this level will also use suck less suck. So that means I need to preserve the inequality like we did last time, and cases on x again. Okay, and now, oh, if I want to left here, I'm gonna get this guy. Okay, I see. And then I can ruffle my feathers, and then what else do we want to do here? We want to. Okay, so now we have the suck k less than or equal to 2. So now I need to rewrite u with 2 equals suck 1. Okay, and now I can rewrite, oh no, I can apply suck le suck at hx, yes. So k is less than or equal to 1. So now I need to cases k, right? Then I can once again actually, do I need to do that? Or can I? Because I unlocked a thing recently, right? I can use this, right? Yeah, okay, hold on. So I have k less than or equal to 1, yes. And then I can prove x equals 1, or no, x equals 0 or x equals 1. Well, the thing is, oh, but maybe I didn't want to use suck le suck here then. Because, no, I did, because I have, because it has to be exactly 1. No, this is still right. But I need to remove the suck. From the goal. So how do I do that? Do I need to do like a right? So I end up with u, but then I can't change like the associativity of the or. So I feel like I'm kind of stuck with this. Okay, what if I apply le 1 at hx? And I get u. So I get k equals 1 or k equals 0. And then I should probably cases u, right? Names. Wait, what am I casing again? I already forgot. Oh, it's an or. A, B, sure. Go do that, I guess. So if k equals 0, then I can just take the middle one. Okay, I see. So I go right, and then I go left, and then I do my substitution. Rewrite ha and then use the power of 0. What was it called? 1 eek suck 0. There we go. And then I can ruffle you. Now I can go right, and then I can go right again. And now we do the same darn thing, except slightly different. So we go 1, or is it 2 eek suck 1? 2 eek suck 1. And then we ruffle. Oh my god! Jeez. This world took forever. Holy moly. That took me like almost 3 hours just to do this one world. Nice. The next step in the development of order theory is to develop the theory of the interplay between less than or equals and multiplication. If you've already done multiplication world, you're now ready for advanced multiplication world. Alright. My god. I do not have time to do this entire world, I'm pretty sure. So yeah. Next time, we will do this one, I guess. I will try to squeeze this into my schedule somehow, because I feel like I should finish this. But yeah, we will be back to doing Star Force Saturdays. So I guess, yeah, this will probably just end up being on the Sunday. Hopefully this one doesn't take as long as this one did. But then again, I don't know. Yeah, yikes. Jesus freaking hell. Alright. I think I'm going to take off now. Because there's absolutely no way I'm doing this in 15 minutes. And yeah, more natural numbers game next weekend, I guess. Because yeah, I want to finish it. I want to finish this off. That stream will be however long it takes. If it's like half an hour, that is a-okay. I do not care. Tuesday will be more Gen 2. I don't know how much more Gen 2 there will be, but yeah, we'll see. And Friday will be more lockpick. All right. Cool. Take care, everyone. Goodbye. Have a good day, evening, good night. Bye.